Completing a Stuart triple expansion engine part 38, mounting the drop arms on the reversing shaft and temporarily fixing them in place to make sure that the expansion links move the correct distance. This image on screen shows the job after I'd finished aligning all of the arms, and if you look closely you can see some felt tip pen marks both on the drop arms and the reversing shaft. This episode is all about the alignment of the drop arms and making sure that I get everything right. I've been putting this job off for a while because it's not something I was really looking forward to doing. The job begins by fitting the reversing screw. There is a bearing just in front of the handle that bolts through one of the upright standards. And here it is with the nut on, holding it in place. This is a critical stage of the operation, finding out whether or not the reversing screw works, and it seems to work okay. The reversing arm is moving around a little bit, but don't forget it's not yet fastened to the shaft in any way. The travel seems to be just about right. I'll find out more about this when I connect the drop arms to the expansion links. This will take place later on in the video. Time now to remove the flywheel. I'm going to fit the eccentric sheaves for the low pressure cylinder first. I have to do this because I need to align each individual arm with the expansion link. Here are the eccentric sheaves, and here are the sheaves fitted in position. The expansion link is in precisely the right place as it's fitting between the valve fork. The principle for doing this job is also applicable to engines that do not have 3 cylinders. The only difference is I've got 3 of everything to contend with. It's really important that these drop arms are perfectly in line with the expansion links, all 3 of them. I'm doing this by eye, but some viewers may need to use a straight edge like a ruler to make sure that the drop arms align with the expansion links. And unfortunately, it's not just a case of making that the 3 drop arms align with the 3 expansion links. I need to make sure that the actuating arm that's connected to the screw reverser is in exactly the right position to move the drop arms, which in turn will move the expansion links their full travel, so it can't collide with anything as I rotate the crankshaft. In this clip you can also see that the drop arm is not in alignment with the expansion link for the intermediate cylinder. I need to temporarily fix these drop arms in place, in what I hope is going to be the correct position, and for this I'm using some Loctite 603 retaining compound. Once all of the components on the reversing shaft are in the correct place and at the right angle, then I will drill through the drop arms, going all the way through the shaft at the points where I want them to be, then use a taper reamer to ream the hole out to a taper, and I will fit taper pins on every one of them. After first applying Loctite 603 to the actuating arm, I left it for a while for it to cure. And now as I rotate the hand wheel, the screw reverser pulls the actuating arm either one way or the other. As you can clearly see in this clip, there is some movement on the die block in the drop arm. This is intentional. I don't want anything to bind in this area. I'm working on the low pressure cylinder valve gear now, and I need to fit the parts that pull the expansion link back and forth. Here you can see the arrangement. Once the expansion link is fastened to the drop arm, as the drop arm moves, so does the expansion link. I did find that there was a slight problem regarding the range of travel, which means that the actuating arm that connects to the screw reverser needs to be slightly offset to the other 3. At this stage though, I'd Loctited the other 3 arms in place, because I assumed that the actuating arm would be in the same position as the drop arms, but this is not so. I need to move the position of the main reversing arm very slightly one way. With the help of my small Proxon blowtorch and a piece of brass sheet as a heat shield, it was a simple job to heat up the joint to destroy the bond of the Loctite. You don't have to apply too much heat for this job, and in no time at all the arm that's connected to the reversing screw was free on the shaft once again, and I could just rotate the shaft very slightly, which gave me the offset that's required. It's really important that the travel of the reversing screw matches perfectly the position of the valve fork over the eccentric rod from each individual eccentric. I really had to think about that one. I never use a script, all this vocal is live. I watch the pictures and speak to the computer. And that's not as easy as you would think. In the real world, when I speak, I have a bit of a stutter or a stammer. It's just one of those things, it's always been there. I think it's caused by my brain giving me too many options on what to say next. In these video tutorials that I make, the narrative has to be completed in small sections. I cannot string too many sentences together before my voice stops making sense. Here's another shot of the cable tie holding the connecting rod in place. And also in this clip you can clearly see that the drop arm of the intermediate cylinder's expansion link is aligned perfectly. When I came to assemble the expansion links with the rods that pull them back and forth, the holes were too small, they were a very tight fit. I want to use standard Stuart 7BA studs, so I drilled out the holes using a number 33 drill. And now the parts fit together far more easily. And furthermore, as these are steel parts, it's important to have some room for the oil between the moving parts. After checking the range of the reversing screw one more time, I came to the conclusion that everything seemed to be in the correct position, so it was time to mark the positions using a felt tip pen, both on the reversing shaft as well as on the drop arms themselves, which are now fixed in place with Loctite 603 anyway. At this stage, I dismantled the screw reverser. Using my small Myford lathe just behind me on the bench, I used a die stock fitted with a 4BA die to cut a few threads on the end of the shaft. I wasn't happy with the 4BA brass nut, so instead I fitted a small acorn nut into the chuck of the Myford. The original thread in this nut was M3, so I drilled it out 1/8 of an inch and rethreaded it 4BA. I didn't like the way that the drop arm went right up against the nut at the full travel of the reverser. I didn't want to fit a washer because that would look ugly. I put the nut back in the lathe and machined it. Even though I still need to clean up the nut with a needle file, you can still see what its function is by machining it as I have done. It's the machined part that contacts the die nut, not the hexagon of the nut itself. You can't see this very clearly in this clip, but by holding a ruler against the standards, it shows me the very small amount of offset of the drop arm which connects to the screw reverser. I think this should be okay. The next job is to remove the cylinder block from the standards so I can drill and pin the drop arms on the reversing shaft. Am I looking forward to that? Well, no, it's quite a fiddly job and not one that I like doing. And that's it for this episode. Stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.